So Groundwater Vistas is one of several preprocessors that allow you to build the files that drive MODFLOW. It's super convenient, much easier to visualize the input than to just use the input files, but it's also really important to know what those files look like. Sometimes it's easier and better to edit those files, and as we'll see later in the class, you can automate some of that editing so that you can build files in a loop if you want to. So today we're going to focus on what those files look like, where you can find more information about what's in the files, and at least give you a bit of a foundation for working with the files directly. We're going to start by running our current model. We'll make sure that all of the output file options are checked, that box down there. We'll also make note of the GV file number that we're running. You can see that in these dialog boxes here. Then in Explore or whatever you're using, you want to navigate to the place where Groundwater Vistas is storing those GWV files. And then you can scroll down and see, in our case, all the GV90 files that were just created when we ran that model. The first file we're going to look at is the name file, .nam. We'll open that with TextPad. There's a video about text editing if you need that reference. We'll open that file. We can see it's a list of names of files, you choose these names, that are used to drive MODFLOW. In MODFLOW you choose different packages to evoke, and you do that by including them in this name file. So this is really the master file that describes the pieces of your model. The first one that we're going to look at after this in order here is the list file.lst. We'll go to that output directory that we found earlier, scroll down to find our GV90 files, and open the list file. This is the main output from MODFLOW. It gives you things like the list of files that have been opened successfully. It shows you the time step by time step mass balance, which you'll use in some of the homeworks. And then also, if you have a problem and the model fails, you'll often find the most useful information down at the bottom of the list file. In this case, it ran successfully and told you how long it took to run. Next, we'll look at the BAS file.bas. It's telling you here what the boundary condition types are. It then also shows you the starting heads, and you'll have one of these matrices for each layer in your model. We have a one-layer model. Next, we're going to open the discretization.dis file. If you type GV90 here, you'll see that it will pull up just the relevant files. It makes it easier to search. Now, there's some things that might be obvious in this. If we look at the top line, we see that it's telling us the number of cells in the model, X and Y, and also the number of stress periods. But we might forget what that number 4 means, so this is probably a good time to show you the online manual. If you do much work with MODFLOW at all, this guide will be one of your best friends. You can see the link here where to find it, or you can just search for MODFLOW online manual. It has all of the packages lined out. So here, if we look at the .bas, BAS6 they call it, we can scroll through and see that each line within the input file is described in detail in the manual. It tells you the format and it tells you the content of each line. A little bit of history about the package, and then scrolling down, let's look at that discretization file for a moment. The first number, the 1 that we didn't discuss, is the number of layers, and then the number of rows and columns and periods. Then we have this IT muni and len uni, and it wasn't clear what those were. If we click the explanation of variables and then click on each of those variables, we'll get further information about that. In this case, we see that the 4 for IT-Muni is telling us that the time units are in days, and our length units are undefined, which would mean that we just have to assume that they're consistent. Generally, it's better to define them specifically. In quick succession then, this is the LPF, layer property flow file. It has the hydraulic conductivity for each layer and each cell. Vertical hydraulic conductivity, specific storage, and specific yield. Next we'll examine the zone file. It has zones for K values and S values, and it also has zones for ET for each stress period. The well package has the layer, column, row, and pumping rate for each well for each stress period. I'll leave you to look in the manual to see the details about the ET package, but basically we're recording the ET rate and the ET depth for each stress period in each zone. The file gets pretty long. But any of these that have matrices, you can imagine that you could go in and edit directly the value for any cell for any time period. It allows you a lot of flexibility that sometimes is not as easy to get to through the GUI. Constant head boundary package, pretty straightforward. Layer, row, column, and the value. This of course could be fixed for each stress period. The .oc file, output control, is pretty important. It tells you what's going to be sent to the list file. Remember that one that keeps track of everything that's happening during a run. And finally we have a couple of output files, and these are binary files, so they look like absolute gibberish if you open them. But if you have the right binary reader, or if you write the right binary reader, you can extract the data from these. They generally will do this for files that can tend to get very large, just because binary will save things more efficiently. That brings us to the end of our quick walk through USGS MODFLOW input-output files. Definitely remember that this is your resource if you want details as you're building your model.